Morning. So today, class, we're going to learn about the ratios of sides, areas, and volumes of similar figures. Okay. So say, for instance, I have one figure that is a rectangle. I think I could draw a rectangle. Can I draw a rectangle? There's a rectangle. Okay. Oh, I can't draw one if it's not the right color. There we go. There's a rectangle. And say I draw another rectangle that looks similar in shape but different size. So say I tell you that these rectangles are similar, and I'll say this is 3, this is 5, and we'll make it simple. We'll say this is 6 and this is 10. What is the ratio of the sides? Side ratio.
2 to 1.
Find the way? Yes? What's the side ratio? Side ratio is 3 to 6 or 1 to 2, right? But let's find the area of this one. What's the area of this one?
15.
15. What's the area of this one? 60. That very good. It's 4 times greater. So the area ratio, in this case, ratio is equal to 15 to 60, which is 1 to 4. Okay? And I kind of talked about this before, but the reason is because 2 dimensions are being doubled, right? Not just 3. So if the ratio of the sides, and so therefore the area ratio is being squared, is the square of the ratio of the sides. So let's go one step further. So say I have just a circle, right? So I should use my circle tool, shouldn't I? Okay. So let's say I have a circle. And where's the other circle tool? Oh, I have to get that one. That's not what I want. The other circle tool. Where's this? How do I get more tools?
So there's a circle right there.
No. Oh, there we go. That's what I wanted. Oh, I know it's not showing up because of my background. So here's a circle, and here's another circle, smaller circle. And let's say that this circle has a radius of 3, okay? And this circle has a radius of 9. What's the ratio of the areas?
1 to 9.
1 to 9. Okay.
Yeah, let's take the ratio as correct.
Sarah, unless you're taking notes on your computer, I'd like to. Okay. So, Brandon.
They're throwing stuff at me.
So the area of this one is what? So the area of this one is pi times 3 squared. And the area of this one is pi times 9 squared, okay? Which is 9 pi, and that's 81 pi. And so the ratio of the areas is 9 pi to 81 pi, which is 1 to 9. Now, you don't really need to do that. I'll go through all that. You don't actually need to find the areas. All you really need to know is that the ratio of the sides, side 1 to side 2, or the radius in this picture, is what to what? What's the ratio of the sides? 1 to 3. So the ratio of the areas is side 1 to side 2 squared. Okay? So that's a conjecture that you have on your conjecture sheet. Equals area 1 to area 2. We'll go through these in a minute. So all you would really have to do is take 1 over 3 and a square. Like that. All right? What if the ratio of the circles was 2 to 5? The ratio of the sides, what if this were 2 and this were 5? Well, yes, then the ratio of the areas would be 4 to 25. See that? You just square that. Very good. All right. Now we'll take it one more step further to volumes. All right. So now we're going to go on to volumes, and that's right. I'm going to go to my gallery. Where's my gallery? Is this gallery? Let's say gallery.
Check.
I think that's, nope, gallery. This is gallery. Okay, I can close that. So now we're going to the gallery. We're going to go to geometry, map. We're in map, right? We're going to go to Dominoes. No, Dominoes is geometry. Oops, up. Going up geometry, 3D figures. I just did 3D figures. There we go. So somewhere in here I have a space. I guess we'll do this one. Okay? Uh-oh, it's not going to show up because this is why I was using black. Can I change that to color? I don't think I can. So now I gotta get a new page. Sorry.
Hey, it's an easy way to erase everything, though.
Day 2. That's why I can't change
Do
it.
background color.
Okay. So now I'm going to get a new page and I'll drag this over here. Ooh, that's good. And I'm going to make a small one of those. Okay? And then I'm going to take one of those and I'm going to go edit, copy, edit, paste. I'm going to get another one of those. I'm going to move it over here. I'm going to make it bigger. Alright? So what I have is two similar three-dimensional shapes. And let's say, even though it may not look like this, let's say that my dimensions of this thing, I better not write in white, are 2, 7, and 3. Let's make it something. Let's make it something that looks like what it is. How about 2, 5, and 6? Okay? And say I were to, okay, here, you can give me that. Thank you. For what? Okay. Okay, so say the dimensions of this are 2, 5, and 6. And let's say that we triple? Double? What do you think? Double? Let's triple. Let's make this 6, 18, and 15. Okay? So what happens to the ratio of the, so what's the ratio of the sides? Side 1 to side 2. It's 1 to 3. Okay? What's the ratio of the areas? Area 1 to area 2. You square these, 1 to 9, right? What's the ratio of volume 1 to volume 3, or volume 2?
1 to 27.
It would be, we think that it's 1 to 27, according to what Harry just said. So you cube this to find this. Just to confirm that's true, the volume of this is 5 times 6 times 2, which is 60. And the volume of this is a big number. 6 times 5, 15.
It's 1,620.
1,620?
Yeah.
Now, so the ratio of the volumes, let's take 1,620. You sure about that?
Yeah.
And divide it by 60. What do I get?
27.
Do I get 27? So the actual, this is the actual volumes, okay? But the ratio of the volumes is 1 to 27. So you have a conjecture on your conjecture sheet that I gave you the other day. Do you have that conjecture sheet in front of you somewhere? right? And it says C98, proportional areas conjecture. That's the first one we did. The corresponding sides of two similar polygons or the radii of two circles comparing the ratio n to n, then the areas comparing the ratio n squared to n squared. Proportional volumes conjecture, that corresponding edges or radii or heights of two similar solids comparing the ratio n to n, their volumes compare in the ratio m cubed to n cubed. Sketch an example. So now I came up with this nice this thing last night. I've been dropping. Hopefully it is updated. Geometry Advanced. I came up with a picture to make it more interesting for you guys. What chapter are we in? 11? Why do elephants have big ears? Look! I made an elephant. Alright?
Do elephants actually wear them?
What? I don't know.
Did you research it?
I didn't research it. Okay? So here's mama elephant, and here's baby elephant, and big mama elephant appears from this picture at least to be.
I promise you that little thing does not weigh 1,000 pounds.
Well,
Yeah.
just deal with it, Josie. Okay?
Close.
You know, and this elephant did what a lot of elephants do: it painted its toenails red. Do you know why elephants paint their toenails red?
Why?
So they can hide in cherry trees.
What?
What? Have you ever seen an elephant in a cherry tree?
No.
There you go.
Mr. Leader, do you know you're recording still?
That's okay. All right. So anyway, a mama elephant, similar in size to a baby elephant, weighs 8,000 pounds. What is the ratio of their heights? Okay. Whoa. What happened to my picture? Where'd it go? There it is. Okay. Oh, I think. I guess I have to annotate on top of this somehow. Okay. So here I go. I'm gonna make the elephants go away. That's all right. So a mama elephant. So if it's a weight, what weight is kind of proportional to what? Its volume, right? Because a weight is a function of how much volume you have, right? Depending on the density of an elephant, right? So the volume of mom to the volume of baby is 8,000 to 1, which is what? 8 to 1. How would I find the ratio of their heights?
I don't know.
What's the opposite of cubing something? Cube rooting it, okay? So you would go the cube root of 8 over the cube root of 1. And the cube root of 8, you should know how to do that under K, is 2. And the ratio, the cube root of 1 is 1, okay? So this is the ratio of their areas, their heights, right? Height mom to height baby. And what would be the ratio of area of mom to area of baby? 4 to 1, very good, 4 to 1. So sometimes if you're given the ratio of the volumes, you can't go directly to the ratio of the height. What you have to do is first find the ratio of the sides or the heights by taking the cube root, and then you square that to get the ratio of the sides. So who could tell me why elephants would have big ears? What? But why? Why would they need to cool themselves off more? Why would like a mama elephant
live in Africa.
have to cool itself off more than what? Right. Because if you take a little baby elephant, and you make it way bigger, right? Its volume. So you say you have this baby elephant that's going up by 1, right? Or going up by a factor of 2 in all the dimensions, right? its volume is going up by a factor of what? 8, right? But its area is only going up by a factor of what? 4, right? 1 to 2 squared, right? How do you cool yourself off if you're a person? How do we cool? Through your sweat, through your pores, right? Through your, which is a function of how much what you have. Surface area, how much skin you have, right? Okay? And so, since elephants have a very low proportion of surface area to volume, they have way more weight, per surface area than we do. So they evolved really big ears so they could have more surface area to keep them cool. Do you kind of get it? Okay. It's what? Well, it's kind of a real life application. All right. Why? Thanks. Why would So other thing, you ever see like really tall people? Like you've seen really tall people, but a lot of like super tall people, like 8 feet tall or something like that. They have a lot of bone problems and stuff like that because how do you support your weight?
Your legs.
Through your feet and stuff, right? And your legs and stuff like that. So they have a way higher proportion of weight to surface area to their feet, right? Than a normal sized person would, right? So, and their bone structure has less proportional strength to support their big frame. Even if they're not fat or anything, right? They still have much more weight per unit area than a regular sized person does. How about that? Did you know that? So that's an interesting fact. Let's do one more problem, and let's do 2 more problems. All right. So say we have this problem, and we have 2. I'm just going to draw them. We have 2 cones. So here's a cone, and here's another cone that's proportional to this cone. Let's say that they're proportional. I'm not very good drawer today. And let's say that the volume. So say all I tell you is that this is 3 and this is 6, okay? And this cone weighs, I don't know.
300 pounds.
300 pounds. 300 pounds. How much does this cone weigh?
No.
Okay? So, in order to figure out the ratio of their weights is proportional to volume, right? So, you don't have to actually know the dimensions, right? Well, I do tell you that these are similar. So, what's the ratio of their size?
1 to 2.
Okay, side 1 to side 2. Let me see. Oh, okay. Okay, side 1 to side 2. Okay. When I'm teaching, I want the computers closed because I don't know if you're looking on YouTube or if you're looking on what. But just close them. All right. Thank you. We have enough distractions as it is. Okay. So what's the ratio of volume 1 to volume 2? If this is 1 to 2, what's the ratio of the volumes? 1 to 8, right? Okay. You just cube it. Yes. And so if this cone weighs 300 pounds, how much does the big cone weigh? You just set it up like that, right? So 8 times as much, so it would weigh 2,400 pounds. Do you understand that? Okay. That's why the Titanic sunk. Why?
That is why
It did?
Yeah.
Yes.
I thought it was
Are you
because
serious?
of this stuff. What?
It's just an iceberg. Have you seen the Titanic?
Iceberg?
Have you ever seen that movie?
Oh. Oh, no, I didn't know it. I didn't know it. No, I knew that. But no, really, the real reason that it sunk, okay, I don't know if it really sunk because of this reason, but say you build a model, say you have a toy Titanic, right? And you float it around in a bathtub, right? Hey, you float it around the bathtub, and it's got a certain weight to surface area ratio. If you make that 1,000 times as big, is that weight to surface area ratio still going to be the same?
Yeah.
No, okay? Because the area goes up by 1,000 squared, but the volume goes up by 1,000 times cubed, right? So it's going to have way more weight per unit area than a smaller model is. So probably it's not going to have the same properties, you know, when you're. So it's probably not going to be as buoyant. Probably you have to change the materials to make it float better and stuff like that. So these are all concerns with engineering and things like that. All right, last one. I just want to look at one of your homework problems, and then we'll be. Then I'll set you free. Not yet. What? Well, oh, it's on page 590. 594. 5. But I want to look at number 10. All right.
4 or 5?
5. Somewhere around there.
5.
So let's go. Don't save. I'm still don't. Oh, look, I can type it right in here. Page 594, 5. This one's at 595. So go. Because this is kind of the problem that gives people a little bit of a headache. Okay? But if you kind of know how to do it. So notice, people say, I don't know how to do this. They don't give me any of the dimensions or anything like that, you know? But, where's my workspace? So here is number 10. And this is one of your homework problems. And it says the pentagonal pyramids are similar. The ratio is are similar. What's the volume of the large pyramid? Does it tell you that? Oh, they want to know what is the volume of the large pyramid, and all they give you is the volume of the small pyramid. Well, if the ratio of the heights is 4 to 7, what is the ratio of the volume of the small to the volume of the big? What's the volume of the big?
64.
Yes, it's 4 cubed to 7 cubed, right? Which is, what's 7 cubed? What's 4 cubed?
64.
That's 64. Anyone know what 7 cubed is?
Well, it's 49 times 7. 343.
343, okay? So 64 is to 343 as volume of the small pyramid is 320 cubic centimeters. So where does that go? The top, as 320 is to be big or something like that, okay? And then you just cross multiply and solve that one. So you don't have to know the dimensions of the pyramid if you know they're similar, okay? And so that's about it. So your homework, which you're going to work on diligently for the next 15 minutes, or work on your nets diligently for the next 45 minutes, is page 595, 1 through 10, 11 through 21 on. Page 595, 1 through 10, 11 through 21 on. Okay? There you go. And I don't know if I'm going to post this, because where's my recorder? There it is. 24 minutes.